Hey, what's up, guys? Today I want to talk about a really fun topic, blockchain. And more specifically, I'll be telling you guys how the Bitcoin protocol works. And but before I tell you how the Bitcoin protocol works, I want to give you guys a big idea of what a blockchain is. So, blockchain, it falls under a umbrella term called distributed system, right? And what is a distributed system? A distributed system is basically a network of computers that works together. The internet is a distributed system. There's a bunch of computers, which are servers, working together to send information. So, and blockchain is basically a distributed system. There's a bunch of computers or nodes working together to uphold this blockchain. So, and within distributed systems, there are two things: a permission and permissionless distributed systems. And blockchain, it falls under permissionless. But what does permission or permissionless mean? So permissionless, you can think of anybody can use this distributed systems. There's nobody that can say no, you can't use this distributed system. It's like the internet. Well, not technically, because your service provider can deny you service. Your internet service provider can deny you your internet service, and you can't access the internet anymore. But not really. But basically, a permissionless system is anybody can use it, nobody controls it. So basically, blockchain. But there's also another side of it, which is permission systems. And this is less decentralized, less you can do anything you want. Somebody actually owns the system. And other than a blockchain, a lot of people don't know about something really similar to blockchain, but which is actually falls under a permission system, which are called hyperledgers. Blockchains. And hyperledgers, it does the same things as blockchains. It does the things that you want a blockchain to do. Everything on a hyperledger is immutable. You can have trustworthy ledgers on a hyperledger. But the thing with hyperledgers is that it is permission, which is it's not decentralized. Somebody actually owns it, and it is kind of the opposite of blockchains in the sense of decentralizations. It's not decentralized at all. But blockchains is not actually heavily adopted in our industry right now because of the fact that it's permissionless. And hyperledger might actually be something that companies will use because it's permission and they can actually control what's on the blockchain. On the hyperledger. Whereas in a blockchain, they can't control it. And hyperledger was actually developed by an organization called the Linux Foundation. And hyperledgers is actually a lot of private companies are actually using hyperledgers. For example, Chase, the bank Chase, and you can see the Chase, they're not using the blockchain like Ethereum to do certain stuff. They're actually using hyperledgers, and within hyperledgers, there's a project called Quota R3, and which is actually quite popular in the financial world. And yeah, so basically, this blockchain falls into an umbrella term called distributed systems, and distributed systems are basically a bunch of computers that work together to achieve a task. And within distributed systems, there are permission distributed systems and permissionless distributed systems. And on the permission distributed systems, there's a project called Hyperledger, and a permissionless distributed system, there's this thing called blockchain. And today we're going to be talking about blockchain. So let me just erase this. And more specifically, I'll talk about the Bitcoin blockchain and how it actually works. So for those of you that don't know, Bitcoin was actually the first blockchain ever created. And we actually call blockchains that mimics the Bitcoin protocol blockchains. That's how the term came to be. Bitcoin was created in, I think it was like 2008, 2009 by someone using the pseudonym Satoshi Nakamoto. And ever since it has been published, people has created various versions of Bitcoins using but with like different consensus protocols, different different cryptographies, and different things, different use cases. But they all fall under this blockchain. So how does Bitcoin work? But before that, I want to talk about more of a general idea what a blockchain is. So a blockchain typically has these three characteristics. It's immutable. I'm sorry if I misspell like a lot of things. I'll probably do that a lot during this video. Anyways, it is immutable, which means a blockchain, whatever you put on a blockchain, you cannot change it. It's like carving out a stone. Once you carve it out, you cannot change it. Okay, so it's immutable. And the other one, decentralized. Now this is a really big thing about blockchains. It's decentralized, which means nobody's own it. It's owned by the community. It's owned by the people that use it. Okay, that's the second one. And the third one is trustworthy. What do you mean by trustworthy? So anything on the blockchain, you will trust it. So if a blockchain says, I have 5 Apple, you will believe, and everybody else that uses this blockchain will believe that I have 5 Apple. So trustworthy. And even though these are the 3 main characteristics, some blockchains, they might not follow these things. Because, like for example, some blockchain, they can be made that without decentralization, without being super decentralized. They might claim that they're decentralized, owned by the community, but they might just be like lying, downright lying, and saying that this blockchain is decentralized. But it can still be a blockchain though, or it can be trustworthy, or the blockchain can actually not be trustworthy. It can actually be a scam. If you guys are following the crypto news lately, this has been a lot of like pump and dump schemes, and so those blockchains will not be trustworthy. And immutable, like some blockchains, they don't like the fact that once you put something on it, you can't change it. So some blockchains might actually be designed so that they might be able to change it. But the main idea of a blockchain is that it's immutable, decentralized, and trustworthy. And some blockchains might not follow these characteristics, but the main ones, the main good one, the main good blockchains should follow these three characteristics. And whoops, I should delete this. And blockchains, they also, you can also think of blockchains as having three different characteristics. And what makes what makes blockchain different than each other? There's also just three main things. So this right here is what most blockchains have in common, and this right here is what separates different blockchains. So the first one, you can think of it as transaction. So what you can think of transaction as what the blockchain is trying to do. What is this blockchain trying to achieve? Is this blockchain used for sending transactions? Is this blockchain used for hosting? Is this blockchain used for NFTs? Is this blockchain have smart contract in it? So transaction is basically what is this blockchain trying to do. And so that's the first one, transaction. What the blockchain is trying to do. Is it trying to facilitate transactions, or is it trying to facilitate smart contracts? And the second one is consensus. So consensus is the decentralization, is the protocol that you use to achieve decentralization. So it can either be proof of work or proof of stake. And since I'll be talking about the Bitcoin protocol, I'll be talking about proof of stake later. But basically, consensus is the method that you use to make sure the blockchain is decentralized. And then the third one is cryptography. So different blockchains might use different cryptographic algorithms. And for those of you that don't know, cryptographic algorithms are like basically ways that you encrypt. It's basically ways that you encrypt. You encrypt data. You encrypt data. You ensure a data's integrity. And I'm actually searching up what's cryptography. But cryptography is basically the method of secure communication, secure actions. So making sure, you can think of cryptography as making sure the thing on a blockchain is immutable, making sure that nobody changes the things on a blockchain, and making sure the thing on a blockchain is actually trustworthy. It's like the methods used to make sure things on the blockchain is immutable, things on the blockchain is trustworthy. Okay, so now I'll start off by talking about how the Bitcoin protocol works. So what is the Bitcoin protocol, the Bitcoin blockchain? What does it do? It is basically a peer-to-peer transaction over the internet without a third party. So peer-to-peer transaction over the internet without a third party. So that means if I usually when I want to send you money to you, it will have to go to a bank. But what if so Bitcoin basically eliminates it. I will send money to you with nobody in it. Well, there is still somebody facilitating this transaction, but it won't be a centralized third party. It will be a decentralized, or it will be decentralized. So basically, you can think of, well, somebody still facilitating it. Yeah, but nobody owns the transaction, the method of transaction. You can think of it as a road on a street. Yeah, I'm still using the road, but nobody owns the road. Nobody can tell me, oh, I can't walk on this road. And that's basically what Bitcoin is doing. You're sending money, or you're sending Bitcoin actually, without a third party. So there's no bank that facilitates the transaction. It's a bunch of decentralized nodes that's sending the transaction. So Bitcoin eliminates the third party when sending money over the internet. So that's what basically a Bitcoin is. The Bitcoin blockchain does a peer-to-peer transaction over the internet without a third party. Okay. So let me just talk about how do you send money over the internet? How do you make sure that this money belongs to me? And when I send the money, it's actually me sending the money, not somebody else sending my own money. Okay, so that will be solved by using cryptography. And within cryptography, there's something called asymmetric. There's something called asymmetric. And basically what an asymmetric key pair is it allows us to send, it's a cryptographic algorithm, and it's actually used in a lot of places, but we can actually use this cryptographic algorithm to facilitate transactions. So in an asymmetric key pair, you have something called a private key, and you have something called a public key. So you can think of a private key as the password to your Chase banking account, online banking account. And you can think of the public key as the username, the phone number, the email that you use when you want to send money to somebody else using Chase. So typically when you want to send money to Chase, you would on Chase you would specify who do you want to send it to. You would put in their email, you would put in their name, or you would put in their phone number. And so that's basically what a public key is. It tells you who that person is, and the private key is your login information. So without the private key, you can't send any money because that's your login. That's the way the blockchain knows that you're actually the owner of this account. So that's private key and public key. So to send money, to send money, you would use your private key, and you would send it to somebody else's public key. And and I won't go into the detail of how it actually works. It's actually the private key and public key, they're actually like mathematically linked, and you basically digitally sign a transaction, and in the blockchain they will verify that the digitally signed transaction actually came from your private key. And that's, I won't go into really deep detail into how it works, but basically your private key is your login information, and your public key is your name, so your phone number, your email address, so that way people know who to send the money to. So that solves the problem of, how do you make sure this money is yours and you can actually send the money. Okay, so once you send the money, how do you make sure that nobody messes with it? How do you make sure that you have like $100 in your account? How do you make sure you have $5 in your account? How do we do that? So basically, we will store everything in a ledger. So every time you send money, the ledger will record it. So for example, Bob sent Alice, $5 to Alice. So every time you send a transaction or you send a transaction, it will be listed in the ledger. So now using the ledger, we can make sure that you actually have this amount of money. You actually have $5 in your account. But then just raises another problem. How do you make sure nobody messes with the ledger? How do you make it immutable? So you would use cryptography, and you would use hashes, something called hashing. And what is hashing? So hashing, you can think of hashing as a mathematical operation where you put something in and it generates a bunch of random stuff. So hash, and you will, for example, you will put a letter. For example, if you put the letter 234541 ASA, a bunch of like just random string of letters and numbers, right? And you put it into a hash, it will then generate a bunch of random stuff, and it will be completely random. And hashes, like after you put just string of numbers and letters into a hash, and it generates just number, like just other random strings and numbers, you cannot revert it. So by just looking at this, there's no way that you can tell what it was before. So after you put a hash in something in a hash, you can't reverse it. So no matter what you do, you cannot reverse it back. Well, if you knew what the thing you put in a hash was, you still have it. But what I'm basically trying to say is, someone else that doesn't know what this thing is, they will never be able to get that thing just by looking at the hash. And this is what's called a one-way hash function. You can't revert something you put in a hash. You can't find out what that thing was before you hash it. And so what you will basically do, and one thing about hashes is that no matter if you just change, if there's like 1,000 word, if you hash like 1,000 word document, right? This is like a Word document, and there's like 1,000 words in it, thousands of letters. If you just change one letter in the Word document, the hash will be completely different, even if you just change one word. And so this feature is really, really helpful. So what you would do is you would hash basically hash this ledger where you store all the transaction into a hash, and it will give you like a bunch of random strings of number. And what you would do is you will put it in the header of this next ledger. So in the next ledger, you would put the hash of the previous ledger. So if the hash of this ledger is 00TRX, you will put 00TRX on the header of the next ledger. So now, if anybody just changes a single letter in this, so somebody want to change this $5 to, let's say, $10, this hash will be completely different. So instead of 00TRX, this hash will give you something like TRX. I'm sorry, that will be like FXT, like something completely different. And there's actually by the way, there's like a lot of SHA hashing algorithms out there, just like the SHA 256, Blowfish. Blowfish is not one. I don't think so. Yeah, actually, it is. But anyways, MD5, SHA 512. Well, they're just basically different hashing algorithms, different way to hash it. So you would use a hash. You would hash the ledger. You would put the hash of that ledger in the next ledger. And in the next ledger, in the header, it will be the hash of the previous ledger. And so if anybody changes the previous ledger, you would know somebody changes it. So this way, you would make sure nobody changes the previous ledger and everything is what it's supposed to be. It's trustworthy, it's immutable, nobody can change it. Okay, so now the last thing, how do you make sure it's decentralized? So basically, you in Bitcoin, you would use something called proof of work. And what proof of work is, it's if you guys heard of miners, people mining Bitcoin, they're basically the people that's keeping up, facilitating the transactions and creating the next ledger. And different people can participate in the proof of work, can participate in mining, and that's how Bitcoin is decentralized. Anybody can participate in mining, and mining is basically operating this blockchain, facilitating the transactions, creating the new ledgers, and that's basically what miners do. They're facilitating transactions, they're creating new ledgers, and anybody can do that. So that's why Bitcoin's decentralized. But how does mining actually work? So using hashes, they will generate a random piece of information, right? So what miners does, no, what the blockchain protocol does is they will say, whoever hashes this ledger and generates a hash that begins with 5 zeros, they will get to create the next block. They will get to create the next ledger. So if you hash this, so what a bunch of miners will basically just keep on hashing this ledger, and they will hope that ledger, the hash. Oh, and by the way, hashes, if you put in the same thing, it will always output the same thing. So if you always put in this into a hash, it will always give you this. And so if you want like a hash to begin with like certain amount of zeros, you would actually have to add something to the ledger. So that way the output of the hash will be different each time you hash it. It wouldn't just be like the same thing. And that thing is actually called a nonce. and it can be it represents a number a number that appears once, so it will be like 1, and then a miner will hash this ledger with the nonce and see what it outputs. And if it outputs, for example, to make the next ledger, the blockchain will say you have to hash this ledger, and this ledger, the hash of this ledger needs to begin with 3 zeros. Okay, so you start hashing it, it gives you 2 0, so it doesn't work. So you will hash it again, but now you will change the nonce to a different number, because if you hash the same thing, it will always give you the same thing. So you will just change the nonce. So you will change it to 2, and now let's say you change it to 10, and after you change it to 10, you hash it. You get something, a hash that starts with 3 zeros in the front. You get to create the next ledger. And how this is done is basically a bunch of miners will buy a bunch of computers, and these computers will just keep on generating nonces, and using the nonces they generated and the ledger, they would hash it into a hashing algorithm, and the hashing algorithm will output a hash. And if the hash that the hashing algorithm outputs begins with a certain amount of zeros, the miners get to mine the next ledger, get to mine the next block, and they will get their reward, their Bitcoin reward, or whatever protocol that they're mining on. And that's just one. This is called proof of work. There's also something else called proof of stake, that blockchains such as Ethereum are moving towards. Blockchains such as Algorand and Cardano are using right now, and it's just basically a different kind of consensus protocol. But I won't get into detail on how that proof of stake work in this video. I might do in a different video. And so this is basically how what's a blockchain, and this is basically how the Bitcoin protocol works. And so thank you guys for watching. I'll see you guys next time.